Hello everyone. So today we will be doing deletion of a node in a linked list. We have completed till here. So after that we will be looking at deletion of a node now. Right. So let's start. Deletion of a node in linked list. So this can be done in two types. First is location of node is given. So what do you mean by location? So here location, this is the address, not index. Okay, so this is the address of the specific node if it is given. I'll explain it later again. Second is when the item of node is given. So what do you mean by item? Item means the value in the node is given, right? Let's start with a simple linked list. So this is the start contains the address of first node, correct? So this is status of first node, so this is the first node. So this node has some value. This is the first node, and it also has, so we'll call this one the item, this one the address. Okay, so this is the item 3, and address will be the address of the next node, which is the second one. This has, suppose item has 5, and then the address of the third node, which is 7, then the address of the fourth node, which is 1. So the last node, so this is the second, this is the third node, this is the fourth node. So suppose this is the last node. The last node is the end of the linked list, so the address of the next node does not exist, which means it is null, which means it doesn't have, right? There is no next node, so it doesn't contain any address in the next part of it, so it will be null. Okay. Some basics about linked list now, how to access items. Suppose address of a node is given by location. Okay, suppose address of a node is location. Now if we write info of location, it means it gives value of node. Okay, if I write link of location, it gives address or next. Okay, as address, let us write this instead of let's use value inside node. Okay, it will give address inside node. This means if location is second node, okay, location is second node, so, okay, so that means this will look like this, 5 and then some address, okay, of the next node. So then what will be info of location? What will be info of location? What do you mean by location of second node? It means this whole address of node, address of node is location. So location means address of this whole thing, and when I say info of this whole thing, it means info of this means it will look at this one, so it will look at 5. Okay, so location in the end is address only, address of a node. It is address of a node. The address of a node, if the location is the address of second node, location is address, it's always address of second node. It means this whole thing address is location, then info of this location will give 5, and link of location will give this address. Okay, this address. Suppose this address is suppose the address is xxx. No, suppose the address is it will be in hexadecimal. No, this address is 4ab3. Okay, something like this, I don't know. And so this link will be 4ab3. What is 4ab3? This is the address of the next node, which is this one, which means link of location is address of next node, that is this one. Okay, this whole address. Okay, the whole address is this one. That's why link location means next one. Okay, because it is address of the next node. It is address of the next node. Link location. Info location is the information of inside the node, which is 5. Link location is address inside the node, which is, what is this address? This is the address of the next node, which is 7. Okay, so this is some basics about a linked list, how to access elements and everything. This is very important, because if you understand this, then you will be able to write algorithms. Okay, now we will look at each of these. First one, second. First is, so these are two types of algos which we'll write. First algo is for when the location of a node is given. Second one, when the item of the node is given. Yes, first. So location is given. We'll take the similar example now. Right. So in this case, what do you mean by when location is given? I mean this whole thing is given. Okay, it means he will give you the location of this one, the address of this location. Like he will give lock, this is the node. Okay, then you have to delete this lock, this location. So there you will give the location address, which will be this node. You have to delete this node. Okay, so let us look at the different parameters in the function. So how will the function look? Writing the function now. Okay, this is the algo. So delete start location of the node, which should be deleted. Next is location previous, which is the location of the previous node of location. So this is will be lock p. Okay, this is lock, this is lock p, and this is start, which is the location address of the first node. It also is taking avail as a parameter. So let us first discuss what each of these terms mean. Right? Let us look at the nodes first, right, to clarity. Here also you can see this is the delete. All go for deletion of a node when location is given. Okay, this is delete, this is the function name. It's taking list. I think it is linked list, but he won't use it. He's just giving this. I don't think it is needed. Next is start. This is the address of the first node of the linked list. This tells where is the linked list starting. Okay, this is. Next is avail. What is avail? Avail is the available space in memory. Alright, that is what avail means. Location, LOC means the location of the node to be deleted, and location P is the location of the node previous to the node to be deleted. Okay, so I'll just write the same for clarification. Where did it go? What is start? Address of, just to decrease this, address of first node in linked list. Right, this is the address of first node in linked list. Basically this node address, this is one. Next is lock. What is lock? Address of node to be deleted. Right. Next, what is lock p? Address of node, address of node previous to the node to be deleted. Basically, if this is lock, which should be deleted, 5, which is this one, the second element. Okay, this one. This is lock, then this is lock p, the previous node. Okay, why do we need this? We will see. We need lock p, but it's important. If log is the node to be deleted, lock p is the node previous to the node to be deleted. That is what I have written. Okay, next is avail. What is avail? This is memory available. Okay, this is memory available. This is the total memory which is available for us. This is not that important, but if he asks, sir, you should write avail, how you will use. Okay. So now we will see how to write the function, how to delete a node when the location of the node to be deleted is given. So this I will write here. Okay, this is function name, starting address of linked list, location of node to be deleted. So this is address. Okay, this is location of previous node. This is avail. So before I write, I want to make sure different cases. So deletion. So how is the algorithm? This is pseudocode which will write. There should be an algorithm also. Correct. Basically the explanation of pseudocode, how to proceed. Okay, so that I will write first here before I write code. Okay. So if this is the linked list, code is already written in the book. so I'll just explain that code. Okay, so you'll have a better idea. This is 7, this is the last node, null. So this is location. Okay, second node is location, this is location P. So what is the main algorithm here is, if this is all given, what you have to do is you have to delete this. How will you delete this? If this is the linked list, you go like this. What should happen if you go here? Address is, so right now the address in the log P is this one. Excuse me. The second node address is here, but we don't need second node now, because second node we want to delete. So we want this address, correct? This is before, the node should look like this, and after deletion it should be like this, correct? 5 is completely deleted. Okay, how will we do this? What we'll do is, in this one we'll put the address of 7. Basically, where is address of 7 right now? Here, correct? If you put this address here, it means this will go away, this address, and we will put address of 7, correct? Now this will happen, this, and this one is gone. 5, no one can access 5 now, but 5 you can access 7. So even this we don't want, correct? Suppose someone gets access to 5, then this is becomes a linked list. No, we don't want this. So what we'll do is we'll put this entire second node into available memory, okay, so that no one will access. This is like garbage collection only, garbage collection. Basically we'll just null everything, we'll put null and we'll put in available memory. We'll just add this to available memory. Okay, so now we will look at the algorithm. We got the code. Before looking at the code, only one special case here. Okay, because this is second node, we got this. But if we want to delete first node, okay, suppose we take this case. Okay, suppose now we want to delete this one. This is lock. Okay, this is a new case, not previous case. This is a different case. Now we want to delete this. This is lock. And where is lock P now? Lock P equal to null, because there is no previous node. No, this is lock P. How will we do in this case? Now if you want to delete, we can't do the same, because lock P address is not there here. Lock P is null. So in this case, it's easy. Basically we put start. We entirely change start address to here. We don't put lock P next or all this. We just put start address here. Okay, so this is the two cases. Now we will write the code for the same. Okay, look at the code once. This is the code. Here you can see the first case is what we have discussed. Okay, I'll just write it again so that you get better clarity. So what we will do, delete start lock P avail, correct? Now we'll start with if log P is equal to null double equal to, which means that if log P is null, which is this case, okay, this case, log P is null, location is given, it means you have to do change start only. But so what we will do here, we'll change start to what should be the start value, new start value. Old start value is 3, new start value should be this one. What is this one? Link location. If you do link location, location is given, link location gives this one, this value, correct? How do you know this? Here you have written link location, you can see. Okay, you can always refer to previous. So link location, if I do, I get this one. So if I do link location, I'll get this one. So same thing I'm doing here. So what I'll do is link location. So you'll get this address, I'll put in start. This is gone now, permanently gone. Okay, but we have to free the memory. Okay, because here it is still accessing 7 now. We have to free this entire thing, put it in available memory. That we'll do afterwards. Next is else. Okay, if this, if not this, then we have to do this, what we have done here. What is this doing? What is he doing here? What we're trying to do here is we have to remove this location. You have to remove. So what we'll do is location, this address is there, no? This address is pointing to location right now, but we don't want this to point to location. We want this address to point directly to this 7. How will we do it? This 7, I mean this whole address. Where is this whole address situated? Here, correct? Correct. Here address is pointing to here. The address here is pointing to this node. So this value, this address should come here. If it this address, this value, if it comes here, then this arrow will come. It will point to here. How will we do this? Basically shift this value to this value, which means else we will do link location p. What will happen when I do link location p? Link location p is this address, correct? This is link location p. This is info location p, correct? This is location p address. If I do info, I get this. If I do link, I get this. So this here, what value should I put? Should put the value of link. Which value? This value. This value. This value is location. So link of location is this value. I'll get link of location. This is this address 7. So this I put in this one. Correct. Now this is gone. Now we have deleted this node. Location is deleted in both cases, but still we have to put the memory of location to available memory. Okay, so this is 2 simple steps he has done. You can do it in many ways, but just for exam sake you can do like sir has did. So what he's doing is link of location. What is link of location? This one. So we don't want this one now, right? So you can see after deleting also this arrow is there. We don't want this arrow now. So what will you do? We'll put this arrow, put the address of available memory. Okay, so it will now point to, suppose this is memory. Okay, avail memory, all memory is there here, like this. So when I do link location to avail, this will happen. Basically it will say that this will have available memory address. And what we will do next is avail will be equal to location, which means that avail will become location. Basically you are taking this whole thing and putting it into available. Making null, and see here in available we are putting location. Inside available memory, location will get put, and even link of location will also be in available. So everything is in available only. suppose we put this avail in location, but link of location is pointing to this arrow mark. If it is there, then it is very much problem. That's why we have deleted everything, and this is over. Okay. Let us now verify this with our code in this data structure. Also you can see if same thing is done. Link location p is null, then start put link location, or else link location p is or link location. Okay, same thing. It is the same code. Okay, so you can go back and understand it again if you want to listen. Here you can see what he has written: removing node to free memory. Basically he's removing the node, putting everything in available memory. Okay, that is what he is trying to do. Okay. So that was this deletion when location is given. Okay, we have done this one now. This is the code. Okay, this is the pseudo code. I'll just put it in bold arrows. Right, and now we will look at second case, which is when item is given. Item is given. What do I mean by item is given? I'll give an example. Okay, first example. So in start, address of first node is there. First node value is 3. In the link of first node is address of second node, like 5. Here address of third node is there. Here address of fourth node is there. Here there is no null is there. This is a linked list. So what do you mean by item is given? Item is given means value is given, like 7 or 5, some value is given, and you have to find that value and delete it. Okay, so item we have to delete. So there may be a question now, what if there are two nodes with the same value? It is entirely possible. Like suppose we'll delete this and we'll put 5 here also, and I say I want 5 deleted. Does it mean that you will delete both 5s? The algorithm which you have been taught in the notes. Okay, so what it does is, in case of case of duplicates, okay, it means same value, that is same value in 2 nodes. Okay, well, in 2 nodes, then what will happen is, then we delete the first occurrence of the value only. What does this mean? This is not complicated English, it's very simple. Then we delete the first occurrence of the value only. Delete the first occurrence only. It means only 5 is deleted. Only this 5 is deleted, not this 5. According to our algorithm. You can write your own algorithm to delete all occurrences also. This also I want to delete, this also I want to. You can obviously do it. But right now we are only doing for first occurrence, only 5 you want to delete. You can try on your own, it's very interesting. But we want to delete only the first occurrence, which means 5 should be deleted and this should be there as it is. How will we do it? Here location is not given. Okay, if location is given of 5, if you know where 5 is, okay, like suppose there is this location and it says this is the address, then you can go directly here and then delete it, like we did in previous case. Location is given and location previous is also given, then we can delete it like in first case. But this is not given. What we are given is 5 is given. Delete 5. They say only delete that much only they say. delete 5. Now what we have to do first, how to do this? Delete 5. So this is similar to insert actually. In insert also there are two cases. No, I think we did insert only one case, but what we do in insert, we say after third node should be the new item which I do, right? So what you do is you try to find the third item and put the new item in third place, correct? We will do something similar here. Okay, so if we say delete 5, what is the process? First find 5, correct? What do you mean by find 5? So first we have to know where is 5. If I don't know where is 5, how will I delete? So I have to go from start to each node. I will check, is 5 is it 5, is this 5, is this 5, 5, 5. If I get 5, then find 5. It means I'll get location of 5 is known. When I find 5, I know the location of 5. Then I'll do first algo only. Like if I know the location of 5, I'll find location of 5. Then I'll do what? First location, first algo edit. If location of 5 is known, I can use the first algo only. Like same logic of first algo I'll put here also. This is the basic understanding here. Okay, two parts we'll try to do. Okay, I think we can write the code now. I hope you understood. Deletion and everything is same. So I'll just write how to find 5. Okay, how does find algo work? Find takes start and item is given. Okay, basically this is the start of linked list. I think charging is I'm just waiting for a little charging. Okay, we got a little charging, but I don't know how much time it will work. So find start and then item is given. Okay, so now we have to just find this item starting from start. So how will we find? Always very simple to start. What we'll do is okay, it is just going so on. We'll start from here. We will keep checking. Like we will go to next one. Like we'll start with location as this one, and location P will keep null. Okay, this is the algorithm which I'm trying to say. And we will check location, info of location will check. If info of location is 5, suppose this is the linked list. Okay, 8 and 5. So it will check. This is 3. Is 3 equal to 5? Basically it will be a while loop. Till this is equal, we will keep checking. Or it is null. We reach the end. Okay. Because if it is not there, the item is not there, then we don't have to delete. Okay. But if we find, we can stop. So till then, what we'll do is we have to go to next. Basically, location equal to link locate next. Then location will become this one. And location P will become this one. Location P. And then if we'll check again info, is this equal to this? No. Then we'll go to here. Location will become location next. And then location P will become, both you have to update because this two should be If this is location, this is location previous. This should be behind only. That's how we will maintain. Why we have to maintain these two? Because when we have to delete location, if you find, we'll see in next case. Suppose we find, like we will go here and in, no, wait a second. Suppose this is only 5, okay, just for example purpose, and this is 8. So here we found 5. What we have to do now? We will delete this, and location P we need because we have to get this address. We have to put this address in here, basically to form this link. This we saw in first case also. In type 1 deletion, we saw this. Why we need location P. So similar algo will do here. Once we find location, this one, then it is the same logic of first one. That is what he has said. Okay. So now we will go to the notes and try to understand what he has written. Basically, you have to understand two things. To delete 5, we have to do, first step is find 5. Once location of 5 is known, then delete location of 5. Correct? Second is do first algo only, same thing. I'm going back to the notes to understand. This is the notes. Okay. So here you can see it started with find logic only directly. So I want to write find. This list is given, but he won't use. This is start of linked list. This is available memory to free memory. Is also basically not that important. We'll start. This is location of the node to be deleted. This is location P. It's actually I don't know why he has taken these two. Basically you need item here. Okay, we'll write the algo there again. Let us write. Okay, let us write. Write in a fresh page. Find start is there and item is there. Okay, basically we are trying to find this item wherever it exists. How will we find this item? First is, what if item like this or not? Okay, let's see how he has done. So what first case, why is he doing? If start is null, suppose location is, suppose linked list is null, basically start is null, it means there is no linked list. Okay, this case we can omit. This is simple case. Start is null, location is null, location P is null. Basically what is trying to say is location is also null, location P is also null, and will return. Basically there is location will become null because there does not exist 5. This 5 does not exist in linked list. If linked list is null, that is the meaning. Next case is info. If info of start equal to, what is he trying to do here? He's trying to say if first location is null, that is what he's trying to say. Okay. He has not written very well. Let us write. Let us write fresh. Okay. This is the start is this location. Okay. This is location. Okay. So what we will do is we will start with this. We will define what is location. It means that location is equal to start. Basically this is start address is given, And next is, so this is location, start address. What is start? Start is first node address, so location also I put here. Location previous is null in the starting, correct? Yes, and now I'll try to find it till the end. Write a loop till the end. Right? If I find in between, I'll go out. So how will I write the loop? You can see here. What I'll do is while till here I want to go, correct? Till here I want to go. It means that while location is not equal to null, okay, the final, this is null, so it will go to location will become null, the final step. Yes, while location. So basically what I'm trying to do here is I'll go to through the entire linked list, each node by each node, by using location, and location previous also I'll keep behind location, and both will go like this, both will go, both will go 3, then 7 and 3, then 5 and 7, 8 and 5, like this, both will go forward till the end of location. If I find the item I want in between, I'll exit, I'll go out of it. Okay, this is what I'm trying to implement. While location is not equal to null, location is not equal to null if info of location, see, I'm doing what I told you before. If info of location is equal to item, correct, then return, because this is location is start only, because location is this only, location P is null. Then you have to do the previous algorithm. Basically we found the item, here, correct? Item is here, it's given, no item, which item he wants. If it is info of location is that, then we return. If it is not this, okay, if it is not this, it means we have to go forward, we have to find it. What will we do if it is not this? We'll go forward. How will we go forward? We will say first we will put our previous one, location P equal to location, okay, location P has moved and location has to go forward now. What is location? Location is nothing but link of location. We are going to next here. What I'm trying to do here? Okay. Location P is null first, okay, and when I say location P, I'll put null. Basically location P will come, this will happen. Location P is null, it's location now, and then location is equal to link of location, or location equal to link of location. This step is very important because this is how you go forward, and you will use this in all linked list algorithms. So location becomes link of location. What is link of location? This is link of location. What is this? This is the address of this. So I'll put location as this. This is location. Got it? Same thing, same formula. I'll keep going forward. Okay. I'll keep this. This else loop has ended here. Okay. else loop is ended here, and then while loop is ending here. Correct? Else we will go forward, and then over while it will go. So is location null? No, the location is not null yet, so I'll go again. So now it will check info is item. If it's item, then it will return, it will come out. Okay, because location and location P are stored. Okay, basically I have to return both here. Okay, if you just return, then location is not there. I think that's why it's put in parameter. Return location and location P, both we want to return here. Okay boss. So return location, so this will keep happening loop till you find location P. If you don't find location P, then location will be null. Okay, right, till last also if you don't. So this is find. Okay, so after find, what will you do? After find, I will call that only. Did you get it? Suppose we use, let's do like what he has done. Location P will put here only, so that this will get updated when we return. Okay. Oh, I know you are not understanding this, but you should write like this only for exam purposes. Pseudocode for sir. This return, and so what I'm trying to do here, I'll just explain briefly. So here we'll return, but location and location P addresses will be in the parameters. Okay, location P are updated as you go through the loop. It is updated. So after you call this function, you can use location. So this is find. But we have to write the main algorithm, no? Main function. So main function will be like this. Delete. This is second type main. Okay, start. Item, which should be deleted. Location P. All this we are taking inputs. Okay. And first what we'll do is we'll call find. Okay. Start item location P. When I do find this it will go, when I find it will go to this function, and this will run, and location start, it will do all this, and location will get updated. So basically the location which should be deleted will get updated. Correct? Location is now location, new location you have. Now what I will do is I will do delete. Or delete first, delete previous function. Alright, delete one. Okay, this is the delete previous function, which we type 1 deletion. This is when location is given. Start location P. I think even avail is there here, so I'll also put avail. Okay, here also you have to put avail, okay, that's all. What will do delete? So what will this function do? Delete one, it will go and call. So see, you can write like this also, or you can write this whole thing, this find logic here only, and then inside you can write delete logic here only. After this you can write here also, you can write, I'll just write delete like first type, because location is known now, location P you know, and you can write the same code is there, no, the same code you can write here. Okay, the same code you can write here and it will run perfectly. Or you can write like this, different functions like find, it will do, and then once location is known, delete. So this delete is that same function, this delete is this function only, delete one. Okay, this is the same as delete one. Okay, same function, delete one function. Okay, so it will run and it will delete. That's all. So that is deletion for today. Okay, I think you learned something. This is deletion, and if you want you can verify in data structures also. The same thing is doing. Okay, I'll just explain. He's using PTR and everything, but I think my code is better. See here, while PTR is equal to null, you can see the code similarities. He has written these different if, but I don't think it is required. Maybe this is required. The first if case, if linked list is only null, then how it will do? Correct? So that is required. And then while PTR is equal to, so PTR is the location which is doing. PTR is basically location I have used, and is doing info PTR. If it's item, then location is PTR and location P is this, or else same equal to PTR equal to link PTR. So this is why he is going forward. Okay, he keeps going forward now. So same means location P, that's why he is using same. So this same, if you see, this same is actually location P. That's why he is written same equal to PTR. Location what I have written is location P equal to location I have written. Correct, I have written location P equal to location. He has written same equal to PTR. Okay, similar. Then PT feeder equal to null. This means if we are come to end, then location is null. Okay. This is anyway happening in my case. Location is becoming null. After this, call delete all go as above, and add this modification to delete all go. Location is null, location is not found, else. Okay, I hope you got this. Basically what is trying to say, if location is null, then item is not found. You have to say no, if location is null. In first algo also you can do. In first algo he didn't put this. If he is put there, then there would be no problem. See, in this case, suppose location is only null, then location is not exist, like that you have to write. Here you have to write if location is equal to null, then print item doesn't exist, location is null, something like that you have to write now. That's what he's saying. Or you can write it here also like he wants. Anyway, I think you got the logic. The code is fine. Code you can write. Okay, that's it for today, and we will meet again tomorrow in the next class. Thank you for listening. I'll send the notes. And we'll keep continuing like this. What else can we do? Correct? Okay.